Okay, so we're going to look at frequencies tables now. So now the frequency table is a way of displaying data. So this is one way of displaying our data. Okay, so we've collected some data and we're now going to display like what it is. So maybe I've collected all your shoe size, yeah, and I'm going to display like the data of that. Okay, so a frequency table will show you a set of data, and then maybe how, and you with it, you'll see the frequency of a certain data entry. So say if I was doing shoe size in here, maybe we collect it, and if I do a frequency table, I'm going to see that there's going to be a shoe size that's most frequent. So when we say most frequent as well, we often refer to it as the mode, but we'll look at that. So a frequency table is a listing of values that a variable takes on, and we often then take frequencies, like so how many, and we change it to a percentage. So say I said, 5 people in this class had a size 8, we've got 25 people in the class, I'm going to change that to 20%. So we often change our frequency tables, have a percentage in there. So just so you remember, so when you're working out a percentage, it's always the amount that you're looking at. So say we were looking at a certain shoe size over the total amount or total number of things, and then you times by 100. So if you're asked to get a percentage or find, it's good to just write this out so that you can make sure that you do it properly. So and so we'll sometimes change our frequencies to percentages. Why do we use a frequency table? Because it will, instead of me seeing a whole list of the data of just say everyone's shoe size is all in one list, if it's popped in a frequency table, I quickly can see what is dominant or what's not so popular. So that's why we put things into maybe a frequency table. So we can see what they say when you see a pattern. In data, we can see a distribution. We see how it pans out. All right, so let's have a look at this question here from an exam. So this is a frequency table here. It says a film was shown to 2 audiences at 2 separate cinemas, Warburn and Yarra Grove. The audience at each cinema was asked to rank the film as good, fair, or poor. So that's actually, what type of data do you think that is? Good. Categorical. And what type of categorical do you reckon? Yeah, I'd call it ordinal, yeah? If someone said it was good, someone said it was poor, there's probably, there's a difference, isn't there? All right, so the results are indicated in the table below. One value is missing, so we can see here one value is missing. Okay, so at Yarra Grove, the percentage of audience. So now I want you to do, when you're looking through your questions and your exams, you have to, whenever they say the percentage, that's what they want, I want you to write down what percentage, like what I said before. It's the amount over the total, yeah, times 100. So then you'll start to see in the question. So the percentage of audience who ranked the film poor. So we're at Yarra Grove. This is the amount and poor. So that's this part. So Yarra Grove and poor. But if you look there, that's this box, and I don't know what that is. But can anyone suggest how we might find that?
Just add those 2 numbers and then...
Yeah. So we can see the total is 250. So I know that this one must be 250 minus the other 2 added together. Yeah? So I get 60, yeah? So we found out this is 60. So this is my amount over. Now they're only talking about Yarra Grove. So what was Yarra Grove's total? Yeah, it was 250. And then you times by 100 and you'll get your percentage, which was 24%. Okay, It says in question 5, which of the following statements by itself supports the contention that ranking given is associated with the cinema which the film is shown? So what we've got this table. I've popped it on the other page, sorry. So we've got this table here, and we've got data. Now, why would we change things to percentages? Because it's hard to compare. You can't compare numbers about the film, because there was more people went to Yarra Grove than the Warburn. But if we're talking about whether people found the movie fair, good or poor, you would have to look at the percentage at that venue. So if you look at the good, so if you want to say that there is a supports the contention that the ranking is associated with the cinema. So if we think that the ranking, we would see a higher percentage of one of those at one of the cinemas. So like we might see that there's a higher percentage of good at one of those cinemas. That's when we can say there's an association. So when you want to say there's something is making an effect, there has to be a difference. So if you want to say they're associated, there has to be a difference in stats. So mainly looking at percentages, yeah? So this first statement, A, over here, it says 65 people at Yarra Grove ranked the film as fair compared to 39. So we can't do that. That's not going to tell me, because it's not a percentage. We need to know, out of the people there, was there a difference in that percentage? So the next one says 64% of Warburn audience thought the film was good, while only 50% at Yarra Grove. Now this one does support, because there's a difference in percentage, and they're also talking about, you have to be talking about the same category to be able to say. So see how they said it was good. So they said that Warburn had 60, when we changed this, was 64%, and this one became 50%. So because we're comparing the same category and there's a difference, we can say they're associated. So the other statements are no good because there's no stats. So the majority of Yarra Grove audience ranked the film good. That's not good, because we're not comparing it to Yarra Grove, the other one. So Warburn, the majority rated it good as well, didn't they? So it didn't matter. So 26% of both Warburn and Yarra Grove audience ranked it film fair. Well, that's not supporting it's associated, because it's the same stat. I mean, that would suggest that doesn't matter what cinema you see it in. So that's not going to help that. And the last one, the audience at Yarra Grove was larger. That's not the stat. That's not what we're comparing. We're saying it's their idea of the film, of their category of the film. All right. So down here is another frequency table. We'll do more of these later on in bivariate data as well. A sample of 26 birds were grouped according to beak size, small, medium and large. So what type of data do we think that is? Categorical and ordinal. Good. Now, the percentage of birds in each group is calculated. The results are displayed. So we just got to remember this is percentage. They've already percentaged it. So now, when you look down at the question, it's saying how many. That's why I start underlining that. How many means I need a number, not a percentage. So they said how many of the 96 birds have a small beak. So I've looked up here and they're saying 25%. So when I want to know how many, change your percentage to a decimal. So 0.25 is 25% as a decimal, and then times it by your total, 96, yeah? And then I ended up with 24. So 25% is actually meaning 25 over 100. So if you change that fraction to a decimal, it becomes 2.5, yeah? If you had, say, this is just off topic, but so just so you know, if you have like 5%, that means 5 over 100. So change that to a decimal would be 0.05. Okay? Yep. Okay, so the following, now we can have two-way frequency table is formed and from the data generated with the entire population of 62 mammals. So here, when they give you this number, they often give it up in the little blurb at the top. That's telling you your total amount. So when you're often finding percentages, that's your total amount, okay? So if we read through our first question here, BI, how many of these 62 mammals had now, we're straight away hopefully, thinking how many, so that we know this is going to be a number answer, not a percentage answer, a number answer. So how many of these 62 animals had both a high likelihood of attack, so likelihood of attack and high, and a high exposure of attack during sleep. So here, so there's the amount. So remember how many, it's just a number, so we write 15, okay? Now in the next question, of these mammals that had a medium likelihood. So right here, of the mammals that have medium likelihood, that is your total. They're talking of those, that's your total amount. What percentage, so we've got to be careful, we want what percentage. So I've seen I need a percentage. I'm going to write this, percentage equals amount over total amount times 100. And I'm doing that, and now I've already said, it says of the mammals that are medium, that's my total amount. So I look down, how many had medium? The total was 4, yeah? So of them, how many had a low exposure? So a low exposure to attack. So we go and look, there's 2, yeah? So 2, and we've got to times it by 100 because it's a percentage. So what will that be? 50%. Okay? And then this question, I'll leave it up because this is important that you copy this so you've got an example. It will say, does the information in the table support the contention? So that's like before when we said, are they associated? So does it support it? Are they the likelihood of attack is associated to exposure during sleep. So what you want to do is when you want to see whether that makes, you want to look at one category. So say if I look at low, so of the low, so if you go to low, you want to talk about the same category and then in one thing. So if I look at likelihood of attack and I look at the low, there is some associated of exposure during sleep. Because if you have low exposure during sleep, the likelihood of attack is low. And if you have, and compared to high, there's a lot of cases of low. So obviously that it does support because there's a difference there, but you've got to compare the same category there. So the percentage of animals with low likelihood of attack decreases with increased exposure to attack during sleep. So that's what I've just highlighted there. See how it decreases? But you have to put a stat. See how it's 2 marks? I've said the answer. Yes, it does, because I can see that it reduces in that category, but I need to put a stat. So I said with 91 to 89 to 11% with high, okay? So we've put the percentages of what's happened there, okay? All right, so, and that's what you need to do. Okay, so we just fixed up those percentages. It was 75, 20, and 5, and that just shows it going down. So we're going to look at bar charts. So bar charts, another way to display data. And you can see that a bar chart, what makes a bar chart is the gaps between here. So remember, you've got columns there, and off it, there's a frequency along the side. But and the frequency can be a count or a percentage. Anyway, but so a bar chart has a gap. So even if you can have a bar chart going that way, yeah, as long as if there's the gaps in here, that's called a bar chart, all right? So what's good about a bar chart is that see here we have a frequency table and there was like 63 countries surveyed or whatever, looked at, and they put their climate into a category of cold, moderate or hot. So here's the frequency table and you can see it's displayed there, and so we can see percentages or whatever. But you see if the data is displayed like this in a bar chart, very quickly I reckon I can see moderate is the most popular, right? So this becomes about what you'll use it in the workforce. No one wants to go into a meeting like your bosses, you're trying to talk about, they go show us this data. This method is going to stand out. Like people can quickly see with one look, yep, what's moderate. So often what we're talking about is we want to know, when we look at bar charts, we want to know the mode, or it could be called the modal category, or sometimes it's the dominant. It just means the most frequent, yeah? So moderate is the most frequent climate for the countries. So we often quote that. So if they say modal category, it's because they might be saying, 0 to 5 years, 9 to 10 years, that's going to be a category. So we say the modal category. All right. So when we describe bar charts, so all about our job now is to give the people the data and tell them what it is. So you report on this, you'd say of the 63 countries, or 23 countries, sorry, classified in their climate, you'd say moderate was the modal, or you'd say the most dominant with 60%, then followed by hot with 26%, and with the least being cold with 13%. So that's all you have to say. When they say report, you say which is higher, go to the lowest, giving a stat. So we're using stats and we're just saying what's dominant and what's not. Sometimes our bar charts can be stacked. So they're like this. So we have stacked bar charts. So what you have to be careful of is first make sure what you're reading, whether it's a frequency or a percentage. But the big problem with the stacked bar charts is often people measure off wrong. So say, for example, if I was looking at the moderate countries, remember moderate is from here to here. So say I had only been given this bar chart. That means if I was trying to work out the percentage from this moderate, from this, I'm going to say, all right, it's between there and there. Yeah? So I would say, all right, I'm roughly on 15 and then I go to 75 or whatever. So I can see that it's 60% in between. What often happens is kids accidentally read off the 70 and say 70. But it's not, isn't there? Because there's a little category underneath chalking it up. So just be careful with that. But also, once again, it's a good way to show, because you can see which colour is the most dominant, and you can then say, well, the modal category. So a boss or someone who wants to know what the data shows them, they probably want to see something like that because it's very quick. They can see within seconds what's going on. All right, so here's an exam question. The development index is used to measure the standard of living in countries. So the bar chart displays the development index for 150 countries. So once again, they often give us a total amount up here. So if you're looking for it, in the 4 categories, low, medium, high, and very high. How many? So be careful, we want a number. So I go and check. Yep, frequency, not percentage, so that's okay. How many of these countries have a very high index? So I go to very high and I go off and I read off here. Yeah? What are we going to say? 31, roughly? Yeah. You'll be able to use your rule across. So we'll say 31. The next question, so it says use these for 6 to 8. The graph below shows the percentage of sales of 3 different types of pasta in 4 different shops. Sorry, the grey one is cannelloni. I've accidentally cut it off, I think. So the first question down here, question 6, the variable sales and shops are. So let's think of if you look down here, they're talking about types of data. So what do you think sales is? Sales, type of data. So I've counted the number of sales. So what do you reckon that is then? That's numerical. And what type of shop, which shop it's in? What do you reckon that is? Yeah. Yep, good. It is nominal. So what's that? Yeah, categorical. Good. But you're right. Categorical and nominal. Excellent. So just to point out, it says so we're going to go with A because we said sales was numerical and shop is categorical. When they say that word respectively, what they mean by that is the first one they asked is the first one they're stating, the second one they asked, the second one, yeah? So that was true, yeah? Numerical, categorical. Let's do this question 7. What is the percentage? So I've got percentage. So remember, maybe look up here, but this is percentage, so that's okay. What is the percentage of sale of macaroni in shop 3? So macaroni is this blue colour in shop 3. So if you look, we're here up to here. So I'm going to say it's like 30 up to 70. So what would that be? 40%. Okay, then question 8. Which of the following statement is true? Shop 1 sold more spaghetti than cannelloni. So spaghetti is the red and cannelloni is the grey. No, it didn't. There's more sections, isn't there? Shop 3 had the least percentage of sales of cannelloni. So does shop 3 have the smallest grey section? No. Shop 1 and 2 sold the same percentage of spaghetti. So does shop 1 and 2 have the same red? No. The percentage of macaroni sold by shop 4 was less than double the percentage of macaroni sold by shop 2. So is the blue in shop 4 less than was less than double the percentage of the macaroni in shop? Is that true in shop 2? What are we looking at? Oh God. 4 and 2. No. So E, shop 1 sold more macaroni than spaghetti and cannelloni combined. That's true? Yeah? How much percentage did it do? 20 to 7. What did it do? 20 to 75. Yeah, that's more than that. So this one. Okay, the segmented bar chart below shows the distribution of people in countries of Australia, India and Japan for 2010. Write down, now remember this is percentage, so write down the percentage of Australians who were aged between 0 and 14. So 0 and 14 is the black in 2010 for Australia. So what do we think? 19. I'm going with that. That looks good. 19%. Awesome. Next one. So we've still got percentage here. How many people in Japan were aged 65 years or over in Japan? So going to Japan and 65. But we've got to be careful. Why do we have to be careful? Because this says how many and this is a percentage. Yeah? So the percentage is, what's the percentage? You're going to go 23? Is everyone happy with that? Look, I'm going to get me ruler out.
You've got a ruler, Jack.
5, 6, 7. 23, good work. So 23% of, now we know, we need the total. So here's the total of Japan. They gave it to me. 128, what's that, million people? So if we're trying to work that how many, change it to a decimal, which is 0.23. Of means times, and then we can do that. And what does that? Sorry, there's the answer. On the graph above, it appears there is no association between the percentage of people aged in the 15. So we're just looking at this. So there's no association. Why? Because there's no difference. They look like the same chunk. So explain why. All three countries have approximately the same percentage. So if you have to read them off, it's 67, 64 and 64. So there's no association because they're not different in one category. If I was trying to show there was an association with, I could say there's an association with the 65 years and over because they're very different, aren't they? Japan have a lot of 65 years and older, more than India. And that makes sense, doesn't it? Because India, their lifespan is not as long because of healthcare. They don't have underdeveloped country. And then where Japan are very, like, they look after their elderly and healthcare is very important. So then that's stuff like that. But we don't have to, as I said, we don't have to give an opinion. But when you're trying to debate, they use real data. So it can help you. Because if you know, people don't survive long in India, it can help you. But they wanted no association because they've used that group